our course, Advanced Directional Drilling. We will divide it, as mentioned before, 2-3 days. First day we'll cover an introduction about direction drilling and why we do direction drilling and the different applications. And the second day, which is important day, where we'll talk about deflection tools, RSS, which is the new technology and recent technology for deflection during direction drilling, and the measurement while drilling, the techniques that give us the surveying or the measurements that we need in direction drilling. The last day ending with the summing up of the 2 days and ending with the design and planning of the direction well, and become a designer for direction well survey each point on the well path. First, we'll talk about an introduction about direction drilling. Directional drilling become one of the most significant and important applications of the direction drilling that solve many issues that cannot be solved during the vertical drilling. As all we over know, the vertical drilling, the drilling of the hole without deviations, without angle, that we put the rig over the site we want to drill and then drill vertically. Directional drilling, can we go through the definitions of the directional drilling? What is direction drilling? Direction drilling can be defined as the science and art of deviating the well from the surface location or from the surface location or target rig location to a target location. As you see in this picture, this is the surface location. In the ordinary manner or conventional manner, we drill vertically as the target beneath lower than the leg. But in the directional drilling, we can, from the same location, drill another target that have a displacement or horizontal displacement between the surface and target location. So the directional drilling is a science and the art of deviating a well bore along the course from the starting location, which is the surface location, to the target location. Both of them, both the surface location and target location, have specific coordinates. Coordinates means the earth coordinates, and we'll go further to explain what is the earth coordinates. The direction drilling, the well, it starts from the concept, how we can do this direction drilling. We start vertically, then we make a kick-off point or make a point to start to deviate. The point to start to deviate, we called it kick-off point, and we'll go further to know all these definitions. Okay, let's start with the history. Where we start the direction drilling. In 1929, the first direction drilling began in 1929 in Oklahoma City to drill blowout wells, whereas the well is blowout and kick. You know the drilling engineering, you have a kick, and if the kick is uncontrolled, will cause blowout and fire. This blowout and fire cannot be controlled from the same location of fire. So we take a kick from far location, about 1 kilo to 2 kilometers, and then we drill directional wells to shut down this well by circulating heavy mud waste. So this is one of the first controlled direction wells in 1930 in California, USA, where it used to hail out the well. Okay, in general, as we know from the drilling engineering, we have 3 types of well. We have 3 types of well. First type well, we call it exploration well or wildcat well. This is the first well we drill in a known or new field to know whether the oil or gas present beneath the earth or not. Is it economics to produce it or not? Then after we confirm the presence of the oil or gas beneath in the rocks, we can go further for appraisal wells. Appraisal wells are drilled to determine the extent of the field, to determine the oil, how much cover this area, where is the limitation of the boundary of the reservoir, in the rocks. Where is the last location we cannot find any oil. Then after determining the boundary of the wells, we go further for development or production wells. These wells is drilled in existing field, not new field. We know the boundary of our field, but it's drilled to increase the production, increase oil and gas production from this field. Okay, why we do directional drilling? Why we need to do directional drilling? Directional drilling is more expensive than the conventional or vertical drilling. It's not easy to do directional drilling, so it takes more cost. It takes recent tools. It takes a lot of effort to do directional drilling. Why do we do directional drilling? First application is called side tracking. As in this picture, we drill vertically, and then there is a fish or some obstruction, some materials fail in the hole, like the drill pipe or any failure of the drill pipe or drill string in the hole happened, and I cannot get it out from the hole. So in the ordinary manner, I cannot go further in the hole, and I will close the hole and go to drill a new hole. But with directional drilling, I go to the drilled path I drilled before. Then when I reach to the problem or the obstructions that makes the drilling stops, I will drill a side track. A side track is the same from the original hole, but it takes a side track with an angle, with increasing angle. Then I reach the target. So the side tracking is saves a lot of time, saves a lot of money, as I use the original hole, and then I deviate from the original hole to the target. Another application which is an accessible location. What does means by an accessible location? Such as in the town or the oil or the target present under the locations of buildings, under the location of gardens, under the location of farms, or beneath the cities, that I cannot move the rig above the target, as is a building is in the picture. I cannot move the rig above the target, so I use direction drilling, as in this picture show. The rig start from we call the horizontal distance called horizontal displacement, about 55 kilometers from the buildings. Then I drill vertically. Then I make a kick-off point. Then I reach the target. This is one of the second application of the direction drilling. One more application of the direction drilling is called salt dome drilling. What is salt dome? Salt dome have been naturally found in the hydrocarbon traps. As we know from the geology, there is a lot of traps. There is structural traps, stratigraphical traps. One of the traps that save the oil and save the petroleum and store the petroleum is called salt dome. The salt dome in the conventional drilling or vertical drilling cause many drilling problem if I drilled vertically, as it deviate the hole for the original location, as it cause corrosion for the equipment, as it cause impurities for the drilling fluid that I drilled. So I deviated from the location of salt dome, and then drill directional wells to avoid these all problems associated with the salt formation. This is one of the directional drilling that's a great application that save a lot of money in solving this problem to drill inside the salt dome. Another application which is called fault controlling. What is fault controlling? Sometimes fault exits in the reservoir, and it causes the storing of the oil, which is the fault is also another type of hydrocarbon traps that store oil inside it. But if we drill vertically, the fault will deviate the well from the original hole. If we drill vertically in the fault, the hole will be deviated outside the target, so it will cause problem So when I use the directional drilling, will drill vertically far from the fault. Then when I reach the target depth, the target of the oil, I drill directional wells, or this simply called horizontal wells. We will know the all types of directional wells. Another applications is the multiple explorations from a single pool. Sometimes in the early time of the field, we need to explore to make appraisal, to make wildcat wells or exploration wells, and sometimes we need to drill more than well. So in the ordinary or conventional well, if I have 3 targets, so I need 3 rigs, and and it will take more time and will take more cost to drill these 3 targets. As in this conventional rig, we have 1 rig here and 1 rig here and 1 rig here, so it will take a lot of time and will take a lot of cost. In directional drilling, I can start from the 1 location and drill this target, and then drill this target and drill this target in 1 time, and when using 1 hole. This is save a lot of cost, save a lot of money, save a lot of effort, and give more information about the wells and the hydrocarbon accumulation under the reservoir. Another application and great application is drilling onshore drilling to offshore location. What's meaning of onshore drilling to offshore locations? So sometimes there is oil under the water, but it's close to the shore, close to the earth, close to the land. And the offshore rigs, it's cost more than the land rig. It's cost a lot of money rent than the land rig. So I can use the land rig and then use directional wells to drill beneath the river, beneath the sea. So I save more money and save more time. Another application of the direction drilling is is this voice clear or not?
Sir, it's breaking, so please check it out.
Okay. Is it clear now?
Yeah, now it's okay, sir.
Okay now?
Okay, sure.
Okay. Another application of direction drilling is offshore multi-well drilling. The same concept from the multi-target inside the land rigs is called offshore multi-well drilling. In the offshore rigs, as I mentioned, the offshore rig is very expensive, and it takes more time to set up in the offshore. So I can drill many targets by one rig. So can in economical way, several directional wells can be drilled as called multiple well or clusters. The one of the most oldest application is relief well. What is relief well? As I mentioned before, if the wells is kicked out as an uncontrolled well, and I cannot control the kick, then the well is blowing, and there is a fire on the well. I want to shut down this well, but I cannot shut down this well from the surface location. So I take another rig from far location, then I drill directional well to hit the path of the old relief of the old blowing well. Then I circulate a kill mud weight or mud, the drilling fluid, which is emit with high density to kill the well from far location than the fire location. About the last two application, which is the multilateral wells. The multilateral wells will have different holes originating from the same place, as the target or the formation can have the oil in different directions. So I can drill a borehole from the right direction, from the left direction also, if the oil is another layer, can, and from one location, with discrete application. Last type of application, or may call it type, which is horizontal drilling. Horizontal drilling, which is drilling vertically, then horizontally drilling. The horizontal drilling, the angle in horizontal drilling will be 90 degrees. The horizontal drilling is used to cover low thickness formation, or it used to cover isolated formation, or cover when the formation have low horizontal permeability. Some formation have low horizontal permeability, so it's have only vertical permeability. So I need to use directional well and use specific horizontal drilling. Also, yes, sir. Okay.
Your voice is lagging, sir.
Also there is a problem in the voice.
Yeah, somewhat. So please once check it out.
I am
once check it out again.
Connection. Again, this slide. Again for this slide, or not? Did you hear me?
Voice is lagging.
Again, okay. We said that the directional wells can be used at multilateral wells when have different well bores from when the oil is present in different layers. In horizontal layers, we want to drill in two directions, from the right side and the left side. Also, when the oil present in another layer, also we can drill from the right and left side. All of these formation, or these target can be drilled with only one rig and from one location. Another directional well application, and the last one, is horizontal drilling. Horizontal drilling is drilling vertically, then drilling with deviating well. Reaching in horizontal drilling is the directional well, but the angle of deviation is 90 degrees. When 90 degrees, it will be horizontal wells. There is three types of horizontal wells. There is short radius well, medium radius, long radius, according to how many foots its exposure horizontally. If the short radius, we call short radius if the length of horizontal drilling is less than 143 feet. In the medium, between 200 to 500 feet radius. For long, greater than 750 meters. It used for many application. It's increased the production, but it will be higher cost than the directional wells without horizontal drilling. But it helps in many problems, such as if there is a low horizontal permeability, if there is water cooling, or any water below the formation, if there is any low pressure zones, that is very helpful for the formation. Okay, we will do all of the application. We know the all application, why we do directional drilling, what are the reasons for the directional drilling, and what is the definition of directional drilling. Okay, to understand the directional drilling very well, we need to know some features of directional drilling profile. How we do directional drilling. First, I mentioned before, the well is drilled vertically, then a kick-off point. What is meaning of kick-off point? Kick-off point is the location of the depth where is the well start to build angle, or to be deviated from the vertical. So before the kick-off point, the angle is 0. Before the kick-off point, the angle will be 0. at the kickoff point, it is the start of building angle or start of deviating the well. So we called it kickoff point or KOB. KOB, which is the abbreviations for kickoff points. Then another definitions, it's called well inclination. Well inclination, it is the angle that the well bore deviated from the vertical, which is the angle. This is the vertical, then this is the deviated path. The angle between the vertical and the deviated well is called well inclination. As I mentioned, when the well inclination will be in horizontal 90 degrees. For kickoff point, at the kickoff point, the angle is 0. After the kickoff point, the angle or inclination start to build and start to increase above 0 until I reach the target depth under the target angle. Another definition or feature of directional well profile is called end of build up. First, I drill vertically, then I make a kickoff point to increase angle from 0 to, say, for example, according to the plan, to 30. So I start building from 0 to 30. Then I stop to build angle. The end point of the building or increasing the angle is called end of build up. Then I can hold the angle. What is the meaning of hold the angle? I start to drill, then kickoff point, then increasing the angle and stop at 30, then holding the angle, keep the angle at the same of the end of build up section. So if I build until 30, then I will hold the angle at 30, which is called hold angle. Tangent section. What is meaning of tangent section? After I build up the angle, I held the angle constant for a certain distance. This is the holding angle is called tangent section or holding section. Then when I holding the angle, I will start to drop the angle. Drop the angle means decrease the inclination. If I building the angle and holding at 30, I will decrease the inclination to reach 0 if I will return vertically. So it's called start. This point is called start of drop section. And the last point of the drop section, when I reach the target angle, say, as I said, when start to drop from 30 to 0, the point at which reach the target dropping inclination is called end of drop of section. Then the last feature or last vocabulary of directional drilling is called target displacement or horizontal displacement. What is the meaning of horizontal displacement? It is the horizontal distance between the surface location, and the target location. It's horizontal distance. It's called target displacement, or it may called also horizontal displacement. Also, another feature of directional drilling is called build-up rate. What is the build-up rate? When I increase angle, I increase the angle inclination of full bore by rate. We express the rate as angle per angle or degree 100 foot. Or if I deal with some metric units, is angle or degree per 30 meter of measured depth. So the build-up rate, the rate at which the angle increase. If the build-up rate 5 degrees per 100 feet, means every 100 foot I increase the angle by 5 degrees. So if I start at 100, so the angle is 5. If I reach 200 feet, so the angle will be 10. So the build-up rate, it is about 5 degrees per 100 feet. It is not fixed. It is a change also. It is a change according to the plan. Another feature or another definition is called turn rate. What is the meaning of turn rate? The turn rate it is the rate where the azimuth change. What is the meaning of azimuth? We know the inclination. All of us know the inclination. It is the angle between the vertical and the deviated well. What is the azimuth? Azimuth, it is the angle from the angle from the north direction is called azimuth. What is the turn rate? The turn rate. The turn rate is the change in inclination, is it a change on azimuth per 100 feet. So I can turn right or can turn left. I can turn up and can turn down. This is called turn rate. Is the voice not clear until now? The voice not clear. Can you hear me?
Yes, sir.
Can you hear me now?
Yes, sir. Yes, sir. Yes, sir. Audio is not clear, sir.
The voice is not clear or fluctuating.
Means I think network issue maybe.
Okay, I will. I use the internet connection is stable. Okay, there is one raised hand. Is there any questions or any concern for raising hand? We'll keep it at the final of the discussion.
Oh, just network issue. Just network issue.
Yes.
Just network issue.
Yes. Okay.
Network issue. I think it is lagging.
Yeah. It is now clear. It is now clear the voice, or still the problem interference the voice.
Yeah, now it's okay. You can start.
Okay. One of definition is called true vertical depth. What does I mean by true vertical depth? As you see in this well planning or well path, there is a path for directional well, and there is true vertical depth. True vertical depth of any point or station is the vertical distance from the surface location to the target point. So if I stop here, for example, this is the point. There is two depths. One depth is called true vertical depth, which is the true vertical depth is the vertical distance from the surface location, and one with the angle with the deviated well with the well path, we call it measured depth. So we have two depths in directional drilling. In conventional drilling, there is no there is only one depth. In conventional drilling or vertical drilling, there is true vertical depth as well as vertical. When the well is deviated, where there is a new depth is called measured depth. The measured depth is the actual well path, while the vertical depth, it is the vertical depth of the well. Why we use two depths for directional drilling, or we use measured depth? As we mentioned, the measured depth of any point or station is the distance from well surface to the reference point of interest. If I choose this point, we'll have two depths. This is measured depth and true vertical depth. It is the depth from the surface vertically to this point. We use 2 points from the calculation of directional drilling and directional well profile and the design. We use measured depths. While for pressure control and well control and kick and the float control, we use in pressure calculation use true vertical depths. So we need to measure the 2 depths, as the true vertical depths enter in the calculation of hydraulics, enter in the calculation of pressures, while the measured depths enter in the calculations of the well design and well path and to know how to when to place the well and when to reach the target. Another definition, which is another definitions, it's called horizontal displacement. Horizontal displacement, it is the distance between 2 points along from the one horizontal depth. I think it's also the internet connection, it is still not stable. I think it will be stable now, more better. The horizontal displacement, the feature of directional drilling is called horizontal displacement. Horizontal displacement. Horizontal displacement, it is the horizontal distance between the surface location and the target location. So there is horizontal displacement. We use the horizontal displacement in the calculation of direction well profile. So I need to keep in mind what is the meaning of horizontal displacement. It is the horizontal distance between the surface location and the target location. So as in the picture, allow is HD. It is the horizontal displacement. Another feature of directional drilling is called vertical section. What is vertical section? If we see the well from the upside view, from the top view, if you have taken model for engine drawing or drawing, we have a plan view as a top view from the wells. We see this is the well. Number 1 is the surface location. Number 2, this is the survey point or selected point on the well path. Number 3 is the target location. So this is 1 is the surface location. This is 3 is the target location, and the well path will be straight from the surface to the target location. So if we have I need to know the vertical section. The vertical section, it is the definitions we use in designing directional well, is the distance between 2 points along the well bore. This is the point 1, and this is point 2. From example, this here, the point 2. We need to know the distance between these 2 points as a projection into vertical section plan. So the vertical section is used in the calculation to know this. To know what is the vertical section. All of questions I will be answered at the end. No problem if you cannot hear any part at the beginning of the presentation. Azimuth. What is the azimuth? As I mentioned before, there is inclination, and I explained the inclination. It is the angle between the vertical and deviated well path. The azimuth, it is the angle from horizontal plan and measured from north direction. I see this is the north direction. So if this is north direction, the angle measured from the north direction clockwise in this direction. So any point in the well path, any point of the well path will have 2 or 3 features. The first feature is the measured depth. The second feature, true vertical depth. The third feature is the inclination of this point. The fourth feature is the azimuth. This means the direction. I can drill the well from the. I can have target here, and I have target here. I have target here. So the azimuth that determines the direction of well bore. So if I left to the right or left, it is depend on the azimuth of target. Okay. let's start with the inclination angle. Inclination angle, this slide sum up of all importance definitions or important feature that we should to know about the directional wells. First thing, the first thing, it is the inclination angle. What is the inclination angle? Inclination angle of any well, it is the point from the well path, as it see in this vertical line. We want to know the inclination of this point. The inclination of this point is the vertical angle between the vertical location and the well path location. What is the measured depth? The measured depth, it is the distance measured along the well path from one reference point to the survey point. So this measured depth as in the line, in the arc line, not in the vertical line. The true vertical depth, it is the vertical distance. So if I want to know this is the vertical distance, the true vertical depth is the distance measured from the reference point to the survey point. The definitions, another definition is the kick-off point. What is the kick-off point? Kick-off point, as mentioned before, the kick-off point is the point below the surface location where the well is start to deviate from the vertical. It is to start to build the angle from 0 to increase the angle until reach the build-up section and reach the target building angle. Build and drop-off rates as change in angle be 100 feet. As mentioned, if the build-up rate 2 degrees per 100 feet, so each 100 feet I drilled, the angle increase by 2 degrees. If I drilled and reach the end of build-up section, then I will hold the angle until reach the target. This is called in this section. When I hold the angle, it's called tangent section. Then another profile, we will know all profiles. I hope can make some questions or answer some questions before moving to the second part. As the second first part depending on the first part.
So we'll do tomorrow. Today voice is lagging, so we'll do it tomorrow.
Okay, no problem. There is
Just once check your voice.
The voice is still not clear?
Yes, that's why, no?
Okay. So we'll keep continue and we'll keep the questions. I will try to make the voice more clear now.
Just once check the voice and start again. Just a minute, guys. Sir will start again.